Hi there. In this video, I'm going to talk about lines that are cut by a transversal. The first thing that we have to do is to draw a picture of two lines being cut by a transversal. And in this section, we're going to primarily focus on parallel lines like this. All right, and we'll show that they're parallel by putting a little arrow on them. And then what we're going to do is we're going to cut them by a transversal, okay? So in this photo, we've got two lines that are parallel being cut by a transversal, okay? So let's label this line here as our transversal, all right? And a transversal all it is just a line that intersects two other lines or two or more other lines, all right? So the interesting thing is that once we establish that these two lines are parallel, and this is the transversal, we can make a lot of different, we can draw a lot of conclusions based on the angle measures that are created here and here of this figure. Okay, so the first thing I want to talk about is some areas of interest that are going to help us in this section. So what I want to talk about is just some of the names that we're going to use with two parallel lines cut by a transversal. So the first thing I want to talk about is this area inside of our two parallel lines. All right. So this is called the interior in between the two parallel lines. All right. If we're talking about the outside, then that would be the exterior. All right, so it's really important that we know what these are because we're going to be using this to name things, later on in the video. Okay, so let's take a look at our first pair of angles that are associated with lines cut by a transversal. Okay, the first thing, pair of angles that I want to talk about are these things called corresponding angles. And this is the corresponding angles theorem. And what it says is that if a transversal intersects two parallel lines, then the resulting corresponding angles are congruent, okay? So corresponding angles, these are angles that are in the same position, okay? What I like to think about if I'm talking about corresponding angles is something that corresponds is like the driver's seat in American-made vehicles, okay? It's always in the front left corner, all right? So what we can say is let's identify what corresponding angles are. So if I look at angle 1 right here, all right, notice that angle 1 is in the top left corner of this intersection, okay? If I look over on this intersection of lines, I notice that angle 5 is in my top left corner, and those are going to be congruent. All right, so I can say that angle 1 is congruent to angle 5 because they're corresponding. All right, and we can say the same thing about angle 2. All right, angle 2 is in the top right position. Okay, so we look down here on this one, angle 6 is in the top right position as well. Okay, and so I'm going to say that angle 2 is congruent to angle 6. All right, if we look at angle 3, it's in the bottom right corner of this intersection, and so is angle 7. All right, so I would say that angle 3 is congruent to angle 7. The last one that I would say is angle 4 corresponds to angle 8 because they're in the bottom left. So we would say that angle 4 is congruent to angle 8. All right, and so that's corresponding angles. All right, and so corresponding angles are congruent. The next pair of angles that we have are called alternate exterior angles, okay? And if a transversal intersects two parallel lines, then the resulting alternate exterior angles are congruent. So remember that we talked about some areas in our figure here, all right, that this was the interior, all right, and that this was the exterior. All right, so the space in between the two parallel lines is the interior, and the space on the outside of those two parallel lines is the exterior. All right, and if we're talking about alternate exterior angles, all right, let's start with angle 1. All right, what we know is that angle 1 is congruent to its alternate exterior angle. So if we look at this, this is on the exterior, all right, and we're talking about alternating across the transversal, and that's also an exterior angle, okay? So angle 1 and angle 7 are alternate exterior angles, and those are congruent. So angle 1 is congruent to angle 7 because those are alternate exterior angles. I can come in here and say that angle 2 is also an exterior angle, and its alternate exterior angle would be angle 8. It's on the opposite side of the transversal, and it's on the other exterior portion. And so angle 2 would be congruent to angle 8. And those are our only pairs of alternate exterior angles. The next pair of angles that I want to talk about are alternate interior angles. So remember, if we label our interior section of our two parallel lines, that's what we're looking for. The other sides are exterior, all right? And so from here, what we want to look at, and let's just start with angle 3, okay? Angle 3 is an interior angle, and if I want to alternate from our transversal to the other interior angle, then it's going to be angle 5, all right? So what we can say is that angle 3 is congruent to angle 5, all right? Then we can also come in here and say, well, here's angle 4. Its alternate interior angle would be angle 6. So I can come in here and say that angle 4 is congruent to angle 6. Those are my only pairs of alternate interior angles. Again, they're in between the two parallel lines and they alternate on either side of our transversal. The next pair of angles that we have here are called same side interior angles. And what it states is that if a transversal intersects two parallel lines, then the resulting same side interior angles are supplementary. Now we have to remember that supplementary means that they add up to 180 degrees, okay? So if we're talking about same side interior angles, let's start with labeling that this is the interior and that the outside is the exterior, okay? And so from here, what we can say is that, let's start with one of these interior angles. We'll call it 3. So angle 3, and angle 3, if we're talking about that angle, and it's same side interior angle. So angle 3 is here, all right? It's same side, so we're not going to alternate onto the other side of our transversal, but we're going to look at this angle down here that is on the same side of our transversal that's interior. Now, angle 6 is that angle. And what we can say is that angle 3 plus angle 6 is equal to 180 degrees, okay? And then the same thing can be said for angle 4 and angle 5. So if I come over here and label angle 4 and angle 5, then I can say angle 4 plus angle 5 is equal to 180 degrees. All right, and so those are same side interior angles. Now, the one thing that's also that can be said here is that, you know, I don't want to make sure that I label 3 and 6 as congruent, okay? I know that 3 and 5 are congruent and 4 and 6, and that's why I use one arc here and an arc here and 2 arcs for these other angles, okay? Okay, so using the angle theorems can allow us to, given one piece of information, we can figure everything else out, okay? And so it depends on how you look at it or how you want to use the theorems. It doesn't really matter as long as you get the questions right. But here's what we got. If the measure of angle 1, this angle here, is 60 degrees, then calculate all the other angle measures. So here's what I can say. I'm going to come in here and I'm going to say that angle 1 is 60 degrees. All right. Now, I know that angle 1 is congruent to angle 5 because they're corresponding. And I can come in here and say that this is also 60 degrees. Now I can come in here and say that angle 5 is congruent to angle 3 because they're alternate interior angles. And this is also 60 degrees. Okay, and then I could say, I could do this a number of ways. I could say that 3 and 7 are corresponding angles. I know that those are going to be congruent. And so I could do that and say that that's 60 degrees. Or I could say that angle 1 and angle 7 are alternate exterior angles and that they're going to be 60 degrees as well. Okay, I can also come in here and say that angle 5 and angle 7 are congruent because they're vertical angles. All right, and you can say that with any one of them. All right, but what I know is that given one of these angles, if it's 60 degrees, I can draw conclusions that all these other angles are also 60 degrees. Now, how do I figure out what angles 2, 4, 6, and 8 are? Okay, we can use a number of things. We can use the fact that what we just talked about, that angles 3 and 6 added together give us 180 degrees. All right, so let's actually write that out, that angle 3 plus angle 6 equals 180 degrees. And if I know that angle 3 is 60 degrees, so 60 degrees plus angle 6 is equal to 180 degrees. If I subtract 60 from both sides, I get that angle 6 is equal to 120. All right. Now, if you can do this without writing an equation, that's fine. I just prefer to do that. But here's what I know. Angle 6 is 120 degrees. Therefore, I can then conclude that angle 4 is its alternate interior angle. That's 120 degrees. I can say that angle 2 corresponds with angle 6, or it's a vertical angle to angle 4, and that is also 120 degrees. I can then come in here and say that 2 and 8 are alternate exterior angles. I can say that 8 and 4 are corresponding, or I can say that 8 and 6 are vertical. It doesn't matter. But what I know is that angle 8 is also 120 degrees. So given one angle, I can calculate all of the other angle measures by simply using the properties that we know if I have two parallel lines cut by a transversal. All right, so using the angle theorems, we're being asked the question, what is the measure of angle 3? So now what we want to do is have the ability to set up equations to solve for other angle measures. All right, so in this example, what I know is that I've got two parallel lines cut by a transversal here. We're trying to figure out what's the measure of angle 3. Now, here's what I know. I know that angle 3 is congruent to that one across from it. It's congruent to angle 5, and it's also congruent to this angle 2x minus 3, okay? So however we want to shake it, that's what we got to figure out what's angle 3. Now, what we know is that this angle for x plus 10 and the angle down here for 2x minus 3, these are alternate exterior angles. Therefore, they're congruent. What we can do is we can set up an equation by setting those two equal to each other and say x plus 10 is equal to 2x minus 3. This is what you have to be able to create. And from here, we're just going to solve this for x. So from here, I'm going to subtract x from both sides, and we get 10 is equal to x minus 3. Then I'm going to add 3 to both sides, and we get that x is equal to 13. Okay, so from here, we know that x is 13, but angle 3, we don't know what that is. So we could plug x back into either one of these because they're going to be congruent to angle 3. What I would do is I would plug it into this equation here, all right? And I would say that angle 3, since they're congruent, we can call angle 3 x plus 10. So if I substitute x equals 13 into this, then we get that angle 3 is equal to 13 and then plus 10. And so angle 3 then is equal to 23 degrees, and that's our answer, okay? And we could have also plugged it into this one, all right? If we do 2 times 13 and then minus 3, 2 times 13 is 26, minus 3 is 23 degrees as well. So it doesn't matter which one you use, but just know that that's the answer we're trying to figure out. Because here's what we know. If this is 23 degrees, I know this is 23 degrees. I know that this is 23 degrees, and that this is 23 degrees, okay, automatically. So I know this is kind of a long video, but it's a lot of good information. It's kind of like solving a puzzle, but let me know if you have any questions, and we'll talk to you soon. Thanks. Bye.